I just plug in the 4 before I start my problem.
Because that wouldn't be the second derivative?
Yeah, then if you plug in your 4 before you do your derivative, then it's a constant and your derivative would be 0. So we have to actually work through our derivative here. So, derivative of the first, so the derivative of z is 1 times the second, plus the first, z, derivative of the second. So the 1/2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside. So the first derivative, we get 25 minus z to the 1/2 minus 1/2 z times 25 minus z to the -1/2. But we need the second derivative. So we do it again. 1/2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, which is -1. So that's the derivative of the first, minus the derivative of the second piece. So I'm going to have to do product rule. Derivative of the first, derivative of 1/2 z is 1/2, times the second, plus the first, I wrote too big, derivative of the second. So the -1/2 comes down, inside stays the same, subtract 1 from the power, times derivative of the inside, which is -1. So for the second derivative, we have negative, can I write this as 1/2 times the square root of 25 minus z? You don't have to, but since I'm going to plug a 4 in, I'm just doing that. Then we would have minus, all right, and then we had a 1/2 times that, so that's again okay. This was a minus and then a negative, so plus 1/2 times 1/2 is 1/4 z, 25 minus z to the -3/2. Actually, if I'm going to be consistent, I should write that like I did my others. And again, you don't have to. This just helps me when I go to plug things in a minute. The z was on top, a negative exponent would put this on the bottom. What does a 3/2 mean? Saying the square root cubed. Okay. If we plug in our 4, so we have -1/2 radical 21 minus 1/2 radical 21 plus 4/4 times the square root of 21 cubed. All right, so without a calculator, we would be a little bit limited on what we could do as far as simplifying. At the very least, these are like terms, so I would expect you to put them together. So that would be -2/2 radical 21, or the 2's could cancel. I simplified mine more than this, but assuming you didn't have a calculator, you could leave it like that. Okay? Yes.
I think it might have, iPad is -1/2 21 to the -1/2 power, and then minus 21 to the -3/2. So like,
You just had an extra 2. That 1/2 you just.
I did.
Okay. So 14. We know position is 16t squared minus 18 minus 1. We want the location when the velocity is 0. So first, we have to do what if I want velocity? So that's 32t minus 80, and I want the velocity to be 0. So if you set that equal to 0, t is 2.5. Okay, and then we're going to put your chair down. And then it asks for the position there. So you have to plug 2.5 into your position equation. And if you do that, you should get negative 101. And then it asks for the average velocity from 1 second to 4 seconds. So those are like your x values. How do you get your y's? Plug it into your position. So if I do that, we get, what's negative 65? What do you get when you plug 4 in?
Negative 65.
Average velocity is just slope between 2 points. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We get 0 over 3, which is 0 for the average velocity. All right. 16. We had all of those derivatives. Which of those do you want me to work out?
B.
B.
B should be hard. It should really space.
All right, so on this one, you could do quotient rule. Or, what else could we do?
Product rule and make x and then
You can make an x and negative 2, do product rule. What else can you do?
Subtract the exponent.
Yeah, we could just simplify this. 2x cubed over x squared is 2x. 3x squared over x squared is 3. 4x over x squared would be 4 over x, or 4x to the negative 1. Minus 5 over x squared, so 5x to the negative 2. And then you can just do your power rule. So derivative of 2x is 2. 3 is constant, so that goes away. Bring your 1 down, so minus 4x to the negative 2 plus 10x to the negative 3. Remember, in general, any simplifying you can do ahead of time tends to lead to a nicer answer.
Mm-hmm.
What else?
If I remember how to do it.
G.
Hmm?
G.
The D after G or G.
All right, we'll do D first, and then I'll go to G. Okay. So we can do this, again, different ways. I'm just going to go with quotient rule, I think. We need to review that anyway. So quotient rule is low, d high, derivative of x is 1, minus high, d low, what's the derivative of x minus 1? Over low squared, plus this one, low, d high, derivative of x plus 1 is 1, minus high, x plus 1, d low, derivative of 3x is 3, over low squared. So I get x minus 1 minus x. 3x. I need to distribute the negative and the 3. 3x squared, so that's 3x times 3x. I have negative 3 over 9x squared. But what could you do there? Divide by 3, so you get negative 1 over 3x. You could have brought them up and written the denominators as negative exponents and done product rule, and you would have to do chain rule within that as well, so it wasn't real pretty, but that would also work. Is this one okay? G. Everybody got E, I guess, and C. We didn't ask about this. So we have quotient rule, low. So the denominator. Did you guys do quotient rule on this one? Okay. You could have also made a tangent 5t to the negative 1 and then product rule. Low, d high. So derivative of secant is angle stays the same. Derivative of the inside. The derivative of 3t is 3 minus high d low. Derivative of tangent is secant squared. Derivative of the inside, derivative of 5t is 5 over low squared. As far as simplifying, there's not much to do. You can't combine the tangent 5t and tangent 3t because angles are different. So we really could just pull that 3 to the front. But these other 3 functions just tag along. Minus, we can take the 5 in front. And that's all we can do here. Is that okay? Any others on problem 16 that you want to look at?
Maybe.
So if we jump into our derivative, we have to do power rule. So 5/3 comes down, inside stays the same. Derivative, or subtract 1 from the power, times the derivative of the inside. How will I do the derivative of that inside? So low, d high, derivative of e to the x is e to the x, minus high, d low, derivative of 1 plus x squared is 2x, over low, squared. from here, we can simplify a bit. Okay. Tell me if I lose you. Here's what I want to do. So I have this 5. This would be like e to the 2/3 x. Right? For this, I'm going to take out that e to the x. It would leave me with 1 plus x squared minus 2x. I have a 3 on the bottom. This is 1 plus x squared to the 2/3 and a 1 plus x squared squared. So we have 5. When you're multiplying these, you add exponents. So 2/3 x plus x. So 2 over 3 plus 3 over 3 would be 5 over 3. And I have the x squared minus 2x plus 1. On the bottom we have a 3. 2/3 plus 2 would be 8/3. And that would be my final.
So, where did you get the 1 plus x squared minus 2x?
And I took out the e to the x, I was left with 1 plus x squared minus 2x.
Mostly rearranging probably.
Yeah. Other questions? Anything else on 16? Um, 17, you had to write a sentence telling me what that meant. So when the interest rate is 10%, the repayment costs are increasing $1,200 per year. 18a, dy dx equals sine x sine y over cosine x cosine y, or you could have said tangent x tangent y. B, dy dx is 5x to the 4th plus 4x cubed y minus 3y squared over 6xy minus 3y squared minus x to the 4th. Either of those that you want me to work out. Yes? Oh, we have things to do after your final. Okay, let me put some problems up. Just so we can. Definition of derivative is what? F of x plus h, so that would be 5 minus 3 times f plus h squared minus f of x all over h. So we get 5 minus, can I distribute the -3 and FOIL at the same time? Minus 3x squared minus 6xh minus 3h squared minus the 5 plus 3x squared over h. So the 5's cancel, the x squareds cancel. Everything that's left can be divided by h. Notice how I'm writing my limit. So we get 6x minus 3h. Then if you plug in a 0, you get 6x. All right, B, what do we have to do? What do we do? How do I find the derivative? Both rule. So low, sine of 4x. D high, derivative of cosine is negative sine. inside stays the same, times derivative of the inside, minus high below, derivative of sine is cosine, inside stays the same, derivative of the inside, over low squared, so it becomes sine squared over 4x. So we get negative 3, sine of 4x, sine of 3x, minus 4, cosine of 3x, cosine of 4x, over sine squared 4x. Is that one okay? Probably easier there just to deal with the chain or the quotient rule rather than trying to bring it up with a negative power. That gets kind of ugly. All right, this one on B, what do we have to do? Product rule. Derivative of the first times the second plus the first. Derivative of the second. Derivative of tangent is secant squared. Inside stays the same. Times derivative of the inside, which is 12x squared. So we get 3 tangent of 4x cubed plus 36x cubed secant squared 4x cubed. All right. Number 3, dy dx. So we're going to have to use implicit differentiation here. Derivative of 5x to the 4th would be 20x cubed plus, we have to do the product rule here. So derivative of the first times the second plus the first derivative of the second. Derivative of y is dy dx. So this piece right here is my derivative of the x cubed y. Minus, now I have to do this derivative of the 2xy to the 4th. So I'm going to treat it as 2x times y to the 4th. So derivative of the first is 2 times the second plus the first. Derivative of the second, that would be 4y cubed, and that needs a dy dx. Equals, derivative of 8 is 0. Okay, so we have 20x cubed, 3x squared y, plus x cubed dy dx. Why did I write this with parentheses here? What do I need to make sure I did? So minus 2y to the 4th minus 8xy cubed dy dx equals 0. So everything with dy dx on one side and everything without it on the other. And then over here. Can I factor this out and divide it one step? So I'm going to take out the dy dx and divide the other stuff over it. And I'm being a bad math teacher right now. I'm not showing all my work. But hopefully you guys see how I got there. Oh.
That's what I thought it was too for a second. I was like, because the 4 kind of does mix them up. I mean, you can see a little branch there,
Yeah,
look really hard.
I can see that now. Sorry, that's why I type your test instead of writing them.
I don't know how many typing mathematical problems suck.
It's not fun, actually, it's very
Because
time
inputting keys and getting the right characters and letters.
The equation editor is not great.
No.
Let's do a couple limits. Alright, here's 3 limits. I'll give you a minute and then we'll talk about it.
Yeah.
So if you multiply by 1 plus cosine on top and bottom. Then we have the limit as theta approaches 0 of 1 minus cosine squared theta over theta times 1 plus cosine theta. What is 1 minus cosine squared? It's just sine squared. Okay, so then we can separate this. So sine squared, that means sine times sine. So that's a theta. 1 plus cosine theta. And we have a theorem that says sine theta over theta is going to go to 1 times sine of 0 is 0. 1 plus cosine of 0 is 1. So we get 1 times 0, which is 0. What you guys think? B, when we're doing the infinite limits, what strategy do we use? So we're going to take everything times 1 over x cubed. So that gives us 5 plus 2 over x squared minus 7 over x cubed. On the bottom, that's 8 plus 3 over x squared plus 5 over x cubed. And if x is going to infinity, what's a number divided by infinity? 0. So we get 5 plus 0 minus 0 over 8 plus 0 plus 0, so we get 5/8. And C, we like to try to factor and reduce. Does this factor? No. So we can't get rid of the problem of the 0 on the bottom, so we have to think through it. If we plugged it in on top, we get this. On the bottom, it's going to 0, but you're approaching -3 from the right, so you're putting in something bigger than -3. So you're putting in -2.7, -2.8, -2.9. So it's getting closer to 0, but it's still a positive number. So on the top, we get 11 divided by a smaller and smaller positive number. What's that going to?